So this one here, like I said, okay, remember the gradient graph that we drew? So now instead of the original fx graph, they give you the gradient graph. They ask you to determine what are the stationary point of the x value of the stationary point. So this is actually the gradient graphs. So what you do is this. X coordinate of the stationary point, what does it mean? It means, okay, this is y equals f prime x first. Stationary value here means what? F prime x goes to 0, right? At stationary value, the gradient is always 0. Okay. I think this one is not an issue lah. This one you likely already know. So essentially, how many coordinates f prime x equals 0? Where? One point here and the other point here. Okay? So let's just understand this one. The first one is this. I'm going to use, I think this is the easiest way to understand. First derivative test. This is minus 3. Minus 3 plus minus 3 negative f prime x. Okay, regardless to say, at x equals to minus 3, this is 0. Right? This is 0. On the right hand side of negative 3, is it a positive gradient or negative gradient? It registers a positive value, right? The f, this, remember, this is not the fx graph, it's the f prime x graph. So this register f prime x graph, this is actually a positive value. On the right is also a positive value. Understand? You register a positive f prime x value because the y-axis is the f prime x. Don't get confused. So this guys here is a positive, this is positive. What shape is this? So this one is at x equals to negative 3. It is a stationary point of inflection. This is where it tends to get confusing really, because the graph you're looking at is the f prime x graph. So when I say f prime x is positive, I'm not looking at the gradient or how it's sloping. I'm looking at the y value. So we know that where f prime x is equal to 0, the left hand side register a positive value, the right hand side register a positive value. So this is a stationary point of inflection. Okay, so you're going to do the next one, this point. So there's another point, right? Which is like this one. So another stationary point is where here, this guy here, right? So you just got this guy. You have to go back and consolidate what we've learned today, because if not, it gets very confusing very easily because of the fx graph and f prime x graph. So x, this is 0 on the right and on the left, f prime x. So obviously, when it's 0, the gradient is 0, not an issue. On the right hand side of 0, register a positive value, right? Positive value, because the y-axis registers a positive. Very positive here. On the left hand side, register this side here, register a negative value. So what point? This is negative 0. This right. So at x equals to 0, it is a, yep. This is method 1. First derivative test. Okay. So what Cadence was talking about is the second derivative test. I think this is easier, but you have to understand also. So this is when we know that the stationary value is at x equals to minus 3. The gradient is what? The gradient here is 0, right? The gradient here is 0, right? So m is 0. What is m? M is actually the gradient of the gradient graph, which is the f prime prime 0 equals to 0. So hence, point of inflection. You can do that. So that at x equals to 0, the gradient of the gradient graph here is positive, right? This is positive. So m is bigger than 0, meaning to say d dx. This works as, if you understand what is actually good to know both. So this is hence minimum point. Yeah, this works. So method 1, method 2, please write it down. Concave upwards is, we need f prime prime x is bigger than 0. So B part 1, concave upwards, we need f prime prime x is bigger than 0, meaning to say this is d dx f prime x bigger than 0. So meaning to say d dx m is bigger than 0. So meaning to say I'm looking at the gradient of the gradient graph to be more than 0. In other words, now I'm looking at the gradient of this graph. Okay, so the gradient that is more than 0 is actually here. You take a ruler, this one is increasing. This is increasing. So essentially, meaning to say, the gradient of y equals f prime x is positive. Okay, so this case here, the gradient is positive, this is decreasing. So I'm looking at x bigger than -3. Where and yeah. Okay, so sorry, concave downwards. I did concave upwards. So this is concave upwards. Okay, never mind. I just put this as concave outwards because this is correct. Part 1, concave downwards will mean f prime prime x equals less than 0, meaning to say d dx f x prime x is less than 0. To say that the gradient is negative. So hence, gradient negative is here. Here. It's just f prime x bigger than 0, meaning to say y is bigger than 0. Y bigger than 0 is here. Anything y equals to 0 is anything above the axis. So here, these are all above the axis. Anything above the axis is increasing function. So here, here, and here. Increasing function can be equal to 0, right? So meaning we can equal to -3 there. So increasing function for part 2, increasing function f prime x is bigger than 0, meaning y is equals to 0. So at least 0. So 0. It would be x at less than -2 or x at least 0. Can equals to 0 there. Cannot equals to -2 because it's asymptote.